All right, so this one will be a short video. Should just be pages 11 and 12. We're just going to practice manipulating some waves by changing some things. Okay, so number one, it says draw a wave that has twice the amplitude of this one. So I want something that has twice the height. Okay, I'm not changing anything else. I'm just changing the height. Okay, so if I start going up, okay, but it stops here, okay, I have to double that basically. Okay, so I'm going to go all the way to the top here. Okay, I still need to come down in the same spot. Okay, and now I got to go all the way down here, and then I'll go back up in the same spot, and then all the way back up, and then end in the same spot. So all I did to change amplitude, the twice amplitude, was just increase the height. I didn't change anything else. It started and ended in the same spot. There was the same number of waves, okay, when we got to that last line. Okay, so we did not change anything else but the height. Number two, draw a wave that has twice the frequency. So twice the frequency. So remember, frequency and wavelength are inverse. Okay, so if one goes up, the other one has to go down. So if I want twice the frequency, my wavelength has to go down by half. So if my wave in the original one is basically going to take two lines just for half a wave, okay, that means when I draw my next wave, I only get one line, okay, for half of a wave. Now, I'm not changing the height or anything. I'm not changing the amplitude, so I'm still not going to go past this little line right here or above this line right here. Okay, so what I'm going to do is I can have half a wave in one line. Okay, then I can have the second half of the wave in the other line. So basically, this is what it looks like. Okay, when you want to double the frequency, okay, so your wavelength has to go down by half. Number three, draw a wave that has twice the wavelength. So now I want the opposite. I want wavelength to be longer. So if wavelength is going to go up, okay, my frequency has to go down. So the number of waves has to decrease the opposite way. I want half the waves. Well, if I have two waves, okay, so there's one. Okay, so this is one wave. Here's two waves. So if I have two waves during that time, I can only have one during the same time. Okay, so what I'm going to do is I need one wave in that amount of time. So I'm going to start going down, but I can use two lines for that bottom trough. And then I can use two lines for that crest. Okay, so that would be twice the wavelength. I didn't change the height or anything. I just changed the wavelength. Number four, draw a wave that has half the frequency. Okay, so half the frequency. So frequency goes down by half. This is the same thing as saying you want to double the wavelength. So basically just the same thing we just did. So you kind of see how we can ask it two different ways. So on number three, I wanted twice the wavelength, so I made it longer. Okay, and number four, if halving the frequency is the same thing as saying doubling the wavelength. Okay, so I'm going to take this exact same one. So I want half the number of waves. So if I had two to begin with, I can only have one. So it's basically just going to look the same as number three. Okay, so that's just an example of how we can ask it in different ways. Okay, so moving on to number five, it says draw a wave that has half the wavelength of this one. Okay, so half the wavelength, so wavelength is going down by half. So that means frequency has to go up by 2. So you want the number of waves to double. Well, if I only have one wave, okay, in those 4 lines, okay, if I want to double that frequency, I need to fit 2 waves in that same amount of time. Okay, so basically we're going to start going down. So I need 2 waves in that same amount of time. So there's 1, and then there's 2. Okay, so that is what half the wavelength looks like. You're doubling the frequency, okay, which means you're shortening the wavelength. Number 6, it says draw a wave that has half the amplitude. So this is where we got to make it shorter, but I want to double the frequency. Okay, so double the frequency. Okay, so that means I want to, let's see how many we have in this first one. I have 1 wave. So there's 1, and there's a half. So I have 1.5 waves here. Okay, so it means in the next one, I need to basically draw 3 waves in the same amount of time. Okay, now your drawing doesn't have to be perfect as long as we can kind of figure out what you're getting at. Okay, so draw a wave that's half the amplitude. So if you noticed, it goes all the way up here and all the way down here. Okay, so half of it means I'm going to stop, and I can only go to that line and to the bottom line. Okay, so we're going to try to draw 3 waves now in the same amount of time. Okay, so let's see how we do. So there's 1, 2, 3. So it's not the perfect drawing, okay, but you kind of get the gist of it. Okay, I halved my height. Okay, I never went above or below that line. And instead of having 1.5 waves, okay, now you just kind of see a sloppy 3 waves to fit in that same amount of time. So summary, half the frequency means the same as double the wavelength. Okay, so again, remember that frequency and wavelength are inverse. So whatever you do to one, you got to do the opposite to the other. Double the frequency means the same as half the wavelength. The proper phrase to describe the above answers is to say that frequency and wavelength are inverse. So basically the opposites. So why is it impossible to draw a wave that has half the frequency but also half the wavelength? Because if you shorten the wavelength, okay, the number of waves has to go up. Okay, so if you actually make that wave shorter, okay, it only makes sense that there's going to be more waves in that amount of time. Okay, if you make those waves longer, there will be a less amount of waves in that amount of time. Okay, so that ends that video. So the next video will start on page 13, and we'll actually start doing calculations.